We're going to be looking at example 1, part C in your section 4.4 notes. In this problem, we want to graph the rational function. We're going to start by looking at the information for the graph. So the x-intercepts come from looking at the numerator. So solving that is pretty easy. Solving 2x minus 3 equals 0. We get x equals 3/2. So we see that our x-intercept is around the 1 1/2 mark and then 0. The y-intercept comes from plugging in 0. So if we look at the y-intercept and we do f of 0, we will get -3 over -8, which ends up being about, I believe, 0.375. And double check me on that. Okay. All right. Now we have asymptote issues because this is a rational function. So we definitely have a vertical asymptote that comes from the 0 of the denominator. So 2x minus 8 cannot be 0. We solve that. We'll see that x cannot be 4. Okay, the horizontal asymptote comes from looking at the degree of the function. So since we see that the numerator and the denominator have the same degree, the horizontal asymptote, one way to do it is to look at the leading coefficients. So we get 2 divided by 2. So we're going to have a horizontal asymptote of 1, y equals 1. Okay, we're going to go ahead and put that information on our graph. I like to put my asymptotes in a different color just to show that they're not really part of the graph, they're just guidelines. So over at 4, I'm going to make a dashed line for the vertical asymptote. I'm going to make sure I don't touch or cross through that. And then y equals 1 over here is going to be my horizontal asymptote, which I can cross through if need be. Okay. Also, we had that our x-intercept was at 1 1/2, so that's about right there. And our y-intercept was 3/8, so we'll make that pretty darn close to the origin right there. Okay. All right, so now we're going to take care of the first derivative. This is going to involve using the quotient rule. So we'll start off by squaring the denominator. So we'll have 2x minus 8, that quantity squared. We'll write that up top there, and then the derivative of the top is going to be 2. Then we're going to go ahead and leave the 2x minus 3 part alone, and then the derivative of the denominator is also 2. So we need to clean up the numerator a little bit. When we do that, we'll have 4x minus 16 from that part, and then don't forget this is really a -2. So we're going to have a -4x and then a plus 6 from that part. So these two terms will end up canceling, and it will end up with a -10 all over the quantity 2x minus 8 squared. Okay. All right, so what ends up happening is that our critical point is going to come from the same 0 of the denominator that we looked at with the vertical asymptote. So x can't be 4 again. So we're going to use that in our first derivative test. Okay. So make sure that you look on both sides of 4 in the first derivative. Now, no matter what number we plug in, whether it's a number like 3 or 5 on this side, you're going to be squaring that denominator. So it's going to be a positive down here. So negative divided by a positive is going to be a negative, okay, on both sides of 4. Okay, so that tells us that f is going to be decreasing from -infinity to 4, and then also on 4 to infinity. Okay, there are no local mins or maximums, but we want to be dropping on both sides of that vertical asymptote. Okay. All right, for our second derivative, it may be helpful to write the first derivative in another fashion besides using quotient rule again. You can go ahead and bring that 2x minus 8 upstairs, but you'll have to make the exponent be a -2. So using this to get our second derivative, we would drop the power. So we're gonna have a 20 out in front. We're gonna have 2x minus 8, and reducing that will be -3. And then we have to multiply by the derivative of the inside here, which is a 2. Okay. All right, so multiplying these, we're gonna get 40, and then we're gonna have 2x minus 8, and then that is gonna be to the 3rd power, okay? All right, next up, again, we see that our possible inflection point comes from the denominator, although that's not a good value, so we will just be using that to determine intervals of concavity, okay? So if we plug in a number like 3 on this side, we're gonna get 6 minus 8, which is a -2, and cubing that is a negative. So we're gonna have a positive over a negative, which is gonna end up being a negative or a concave down interval. If we put something like 5, this is gonna be a positive, so positive over positive. We're gonna have a positive right there, okay? So we're gonna say that F is gonna be concave down from -infinity to 4, and then F is concave up from 4 to infinity. Okay, so now we want to put this together. We know that it's decreasing on our domain. Okay, we know it's concave down. So we want to follow the asymptote. Okay, go through our points. Okay, and then stay concave down, follow the vertical asymptote. Okay, when we jump over to the other side of this, we also want to be decreasing. So we know that we are not going to be drawing down in this section because this would be an increasing function. So we want it to be decreasing, and then we want to be concave up. So here would be the section we're looking for. So there's a decreasing, and then we drew it concave up. And that completes this problem.